In this lecture, we're going to look at the MOS regions of operation, and we're going to look at it based on voltage definitions between any two different terminals. So, for instance, we're going to look at the differences between the gate to source voltage, and we'll examine it for both MOS, PMOS, and NMOS transistors. So here we have our NMOS transistor symbol, and here we have our PMOS transistor symbol. And we know that cutoff for the NMOS is defined as the gate to source voltage is low. In fact, the gate to source voltage is less than a threshold voltage. Now, we need to make sure not to confuse threshold voltage and thermal voltage. So down here I have a note saying that V lowercase t is not the same as V uppercase t. V lowercase t we'll use as threshold voltage, V uppercase t is the thermal voltage. Threshold voltage applies to MOS transistors, thermal voltage applies to bipolar transistors. Actually, thermal voltage also has some implication in the MOS transistor, but not in the cases that we're talking about right now. Okay, so for a PMOS device, if we just reverse the subscripts and take the absolute value of the threshold voltage, we can get the same relationship. So we can say that for a PMOS device, it's in cutoff if the source to gate voltage is less than the absolute value of the PMOS threshold voltage. So conversely, if we go above the threshold voltage, we would expect the transistor to be on. So VGS greater than the threshold voltage for an NMOS device, the transistor is on. We reverse the subscripts for a PMOS device, and the transistor is on. Now, the transistor has two modes of operation when it's on. It can be in either triode, where it's acting as a linear resistor, or it can be in saturation. So just make a note, triode is a linear resistor. Saturation, it's behaving like a voltage-dependent current source. So, let's look at the triode. For triode operation, we say if VDS, the drain to source voltage, is less than VGS minus a threshold voltage, then the device is in triode. And of course, the opposite situation, if the drain to source voltage is greater than VGS minus a threshold voltage, the device would be in saturation. For the PMOS device, we just reverse the subscripts. V source to drain is less than V source to gate minus the absolute value of the threshold voltage. The device is in triode. For saturation, V source to drain is greater than V source to gate minus the absolute value of the threshold voltage. With a little bit of algebraic manipulation, we can simplify these statements. Basically, what we can do is expand and say that VD minus VS is greater than VG minus VS minus VT. And we can do a little bit of manipulation here to get rid of the source voltages and come up with a modified expression to check if the device is in saturation. And so if we do that, we would get an expression VGD is less than VT. For the PMOS device, we just reverse the subscripts and say VDG is less than the absolute value of VT, and that would result in the transistor being in saturation. Now, to look at what we mean by saturation, by operation in the saturation region, we're going to plot the characteristic curves of the transistor. So here we have drain current plotted versus drain to source voltage. And just like a bipolar transistor, we would get a family of curves depending upon what we set the gate to source voltage at. So each of these curves corresponds to a different gate to source voltage. And of course, we're looking at this plot for an NMOS transistor. We'd have a similar plot for a PMOS transistor. Okay, so we know that no current flows in the devices in cutoff. So basically, cutoff corresponds to this point here. And of course, it would correspond to no current flowing if the drain to source voltage is raised. Now, when the transistor is on, we can separate the region similar to how we separated it for the bipolar transistor. When the drain to source voltage is low, this is the triode region. When the drain to source voltage is high, this is the saturation region. The voltage level that this happens at we commonly label as VDS sat, and sometimes we also call it VOV for V overdrive voltage. Okay, we're going to look at the regions of operation of a MOS transistor in more detail in the next sections.